So in this example, we'll see again how do we work with the statistical test. So the Environmental Protection Agency has been studying Miller Creek regarding ammonia nitrogen concentration. For many years, the concentration has been 2.3 milligram per liter. So this is the concentration from many years. Okay. However, a new golf course and housing developments are raising the concern that the concentration may have changed. Concentration may have changed because of the lawn fertilizers. So it is means may have changed. We have this keyword here. Okay, from many years it has been 2.3 mg per liter, and now it's changed. Any change in the ammonia nitrogen concentration can affect the plant and animal life in and around the creek. Let X be a random variable representing the ammonia nitrogen concentration. Based on recent studies of Miller Creek, we may assume that X has a normal distribution with sigma is equal to 0.30. Okay, so this is the standard deviation. Recently, a random sample of 8 water tests from the creek gave the following X values. Now for this, we have to construct a statistical test to examine the claim that the concentration of ammonia nitrogen has changed from 2.3 milligram per liter. Use the level of significance alpha as 0.01. So we have the value of alpha here. Let's see what else we have. Now, first of all, we should have the null hypothesis and the alternative hypothesis. Null hypothesis, it means we go with the claim and what the test is saying about. So we say that from many years they said that the concentration has been 2.3 mg per L. So we go with it and we say that presently also it is same 2.3 milligram per liter. It's not change. Okay, so this is your mu. Now what they said, there are the concerns that it may have changed, and also it is mentioned that we have to construct a test to examine the claim that it has changed. Changed means it's different than 2.3. So for change we use the symbol not equal to. So our alternative hypothesis become this one. Okay, now let's see what else is given. We have sigma. Okay, we have the value of sigma, which is population standard deviation. Recently a random sample of 8 water tests. So how many? 8. So the sample size is 8. Now we don't have the sample mean. So from population we have mu, which is 2.3, and the standard deviation, which is 0.3, and from the sample we have sample size, which is 8. We need the sample mean also, because now we already have the population standard deviation. It means we can go ahead with the Z test. Now population mean or average is not given, but these numbers are given to you. So you can find average using this, which gives you 2.15. Sorry, it is 2.51. 2.51. So now we have the sufficient information to do our calculation. Now population standard deviation is given, it means it is Z test. Now find the value, Z value, which is x bar minus mu over sigma times square root of n, When we substitute all these values, what we will get here? X bar 2.51 minus mu, which is 2.3, over sigma, which is 0.3, times square root of 8, which on calculation this is 1.979. This is the Z value by calculation. Okay, now we need to calculate Z value from the table. Now from the table, what we need to calculate Z value from table, we need the level of significance first, which is 0.01, or you can say 1%, and the type of test. Now it is equal, not equal. Alternative hypothesis is not equal, so it is two-tailed test. Two-tailed test. Now we look at the Z table for this. So now if we look here, now we have two-tailed test, and this last row is giving you Z values. Now we need it for alpha is equal to 1% or 0.01, which is this column. So in this column, the last value. So our value is 2.576. So we get the Z value from table as 2.576. Okay. Now we use this value to plot the critical region. So Z value, let's write it down from the calculation what we got and what we got from the table. It is 2.576, and from here it is 1.979. Now we use this tabulated value to give you the critical region or the region of rejection. So we'll follow the same process as we did before. We plot the positive and negative of this point, 2.576 with minus, and this is the critical region. Okay, so if I write critical region by CR, this is the critical region, the region of rejection. Now check where our values lie. Our calculated value is 1.979. So it will be somewhere here, 1.979, which not lies in the critical region. So we say that as Z from calculation, which is 1.979, not lies in the critical region. Now we are making the conclusion. Okay, hence do not reject H0, the null hypothesis. And what was the null hypothesis? That null hypothesis is that the concentration is still 2.3 mg per liter. So we concluded that mu is 2.3 gram per liter. So the concentration of ammonia is not changed.